All right, here we go. We're on 23. So, um, so when we do limits, we try to plug the number in right away or do some factoring and canceling and plug it in. But we can't do any of that here. So then we rely on whose rule? L'Hopital's rule, where we take the derivative of the top, derivative of the bottom. What's the derivative of the top? Cosine of pi over 2 plus x minus 1 disappears times the first derivative of the inside, which is 1, over the derivative of the bottom, 1. So now if we put in the 0 for x, we have the cosine of pi over 2. What's cosine of pi over 2? 0. 0 over 1 is 0. Okay? Good old L'Hopital's rule. Yep. And so take the derivative of the top, derivative of the bottom. All right. Kylie, they're talking to you. All right, the next one. This one's a little bit squirrely, but it's not horrible. Okay? All right. You're supposed to find y when x is 3 if we know originally y equals 4 when x equals 2. Okay? So, originally, what we can do is multiply both sides by y and multiply both sides by dx. So y dy equals 3x squared plus 2 dx. Okay? And then, what do you think we do? Integrate. So 1/2 y squared equals x cubed plus 2x plus c. Okay? Then we put in the numbers to figure out what c is. So we put 4 in for y. So 1/2 of 16 equals 8 plus 4 plus c. So 8 equals 8 plus 4 plus c. So c equals -4, basically, right? Okay, so we grab that function, 1/2 y squared plus or equals x cubed plus 2x minus 4. Okay, when x is 3, what is y? So 1/2 y squared equals 27 plus 6 minus 4. So 1/2 y squared equals 29. How do I get y along? Multiply by 2 and take the square root. Choice D. Okay, 25. Gotta know this formula. Plain and simple, gotta know this formula. It's the second one down over there, the tangent one. It's 1 over the whole number of the square root of that. So 1 over 3 equals the inverse tangent of x over 3. Okay? Because it's the integral of dx over 3 squared plus x squared. So it's 1 over this plus inverse tangent of this over this. Okay? You have to memorize that formula. Yep. And I'm going to hand out a cheat, or not a cheat sheet, but a formula sheet of things that, and I'll go over which ones I really think you need to know. You don't, yeah, you're supposed to know everything on it, but obviously the ones that might not be memorized that you need to know, I'll go over those. All right. First derivative of this. Well, this whole thing, because it's written this way, it can be kind of confusing. So I would rewrite it as this. And then it's not so confusing. Now take the first derivative. Well, you have to use the what rule? Chain rule. Chain, chain, chain. Chain rule. All right. So 3 cosine of x plus 1, quantity squared, times the first derivative of the inside. What? First derivative of the cosine of x plus 1 is sine. Negative sine of x plus 1 times the first derivative of x plus 1, which is 1. Okay. So what is it? Well, it's 3 cosine squared of x plus 1, negative sine of x plus 1. Well, if it's pi, throw a pi in there, but it's negative 3 cosine of pi plus 1 sine of pi plus 1 because of that negative. Okay, I don't remember if we did integration by parts in here. I don't think we did. So usually you'd look at this and think, okay, I got to take the integral of the inside. And so what is the first? So u would be x plus 3, du would be 1 dx. But there's an extra x sticking out in front of there. So you can't quite do it that way. So you still say u equals x plus 3. So x equals u plus 3. So what is this really? Well, it's the integral of u minus 3. Thank you. It's the integral of u minus 3 times u to the what power? X plus 3 is to the what power? The square root. So it's u to the 1/2. So if we distribute, it's u to the 3/2 minus 3u to the 1/2 that we're going to take the integral of. Because if you distribute, this is u to the first. 1 plus 1/2 is 1/2, which is 3/2. Add 1 and 1/2. I can't add fractions. Oh, sorry, doodad. So how do we integrate u to the 3/2? It becomes u to the 5/2. Multiply, add 1 to it with a 2/5 in front of it. U to the 1/2 becomes u to the 3/2 with 2/3 in front of it, so it's a 2 plus c. So you have 2/5 x minus 3, or x plus, because it's u, so it's x plus 3. 2/5 that minus 2 u to the 3/2 plus c. Okay? So that's one that I don't remember that we did in here, but it could be on there.
So I got a question for you.
What?
Things like that square root, is it ever going to be over anything? Like over 3, over 2, over 3? Like, should you always just X those out? Do you get what I'm saying?
No.
Dude, I like how that's a thing.
I don't know what you're asking.
Where'd you get u to the 1/2?
U to the 1/2 is because x plus 3 is to the underneath the square root, so it's to the 1/2 power. All right. The first derivative of this. The first derivative of the ln of 1 minus x. All right, so again, chain rule. Okay, what's the first derivative of the natural log? 1 over whatever's behind it, which is the ln of 1 minus x, times the first derivative of the inside. What's the first derivative of the inside? 1 over 1 minus x, times the first derivative of that inside, times negative 1. Okay?
It's not B, it's D.
So then it would be D.
Dang, good base though. Dude, no,
I almost had.
we should do it all by ourselves and then have people.
You should have done it all by yourselves when I handed it out.
Yeah, except for I looked at them and I had no idea what.
28 pages full of math problems. Yeah, I'll confirm that. I don't know how to do any of this.
You do know how to do it. You-
I haven't seen a single problem that-
Okay, Trey. All right. So, what's e to the 0 power? 1. So, if we put in 0 right away, we get 0 over 0. Can't do it, so we have to do L'Hopital. So, it's x times the first derivative. What's the first derivative of the e to the x? No, it's e to the x, man. Come on. The first derivative of the e to the x is e to the x. Plus, that's an x. The derivative of the top, derivative of the bottom. Plus, the derivative of e to the x is e to the x. So it's x times the first derivative of the e to the x, which is e to the x, plus e to the x times the first derivative of x, which is 1, over the first derivative of the denominator, which is negative e to the x. Now, let's factor out e to the x. So it's x plus 1 over negative e to the x. The e to the x's cancel. So it's x plus 1 over negative 1. And if we put in a 0, we get 1 over negative 1, which is?
My question is, how come you're taking the derivative of the EX but not the X? Because X.
We are.
We did. It's the power or product rule.
Where did you get x plus 1?
It's the first times the first derivative of the second plus the second times the first derivative of the first.
Wait, hold on. Where did you get x plus 1?
Because we factored out e to the x.
Right here.
If we factor out e to the x, there's an x left here and a 1 left here.
How come you got 1? Where did that X go?
Now it's
I'm just confused on how you got negative 1.
Because it's negative e to the x on the bottom.
Oh, so it's just negative 1.
And if we put in a 0, 0 plus 1 is 1 over negative 1 is negative 1. All right. So, what's the first derivative of tangent? What's the first derivative of tangent?
It's tangent secant.
It's secant squared. You gotta memorize those. Okay? So if x is tangent of x, then the first derivative of that is secant squared of x. So this secant squared of x dx. So if u equals tangent of x, what's du? Secant squared of x dx. So we have u to the 6th du, right? Well, what's the integral of u to the 6th du? 1/7 u to the 7th plus c. What's your choice A?
I can do that one.
Okay, so that ends the non-calculator section. Where a couple of them I say, boy, that's really hard if you don't have a calculator. Now, some of these on the calculator section, actually, you don't need a calculator at all. Okay, I don't understand. So maybe for our diagnostic, we'll do the calculator section, which is only 15 questions. And it's 45 minutes because we have a 55-minute class on Wednesday. We're only doing one because that's all we have time for. And then Friday will be the last minute review of everything we need to review because Monday's the test. Yeah. All right. Tuesday. All right, here we go. Shh. So for this one, we could put this straight into our calculator. Now, if you don't know how to run your calculator good enough, we're going to even teach you a little bit more today. All right. There we go. Since you're going to a farm school, you don't think they have calculus? Oh my. Guess what? It's an engineering school too. So it's not just a farm school. So yeah. Does USD have engineering? No. No, they have mechanical engineering, electrical engineering, chemical engineering, all that kind of stuff. So yeah. Okay, here we go. Hey, calculators out. Ready? So what I want you to do is push alpha, F2. The green button. And now press 4. What comes up?
No way!
You hate me. Thank you very much. Because you need to learn the process, not just how to punch it into the calculator. If I would have taught you this before, you wouldn't have learned what to do. So pi divided by 4, then you go down here, sine of x, and then you have to put an x behind the dx, and then plus second f2, alpha f2, sorry. Alpha f2 again, 4, and then it's negative pi over 4 to 0 of the cosine of x dx, enter, and you get 1. Okay, now. I don't care. All right, so let's say you want to know how to do this without a calculator. Well, the integral of sine is negative cosine from 0 to pi over 4 plus sine from negative pi over 4 to 0. So negative cosine of pi over 4 is negative square root of 2 over 2. Cosine of 0 is 1. I think it's Christensen now. I think Howell will be gone. Plus the sine of negative pi over 4 is the negative square root of 2 over 2. The sine of 0 is 0. And yeah. Yeah, put it in your graphic calculator. Okay, here we go. Particles move along the x or along the y-axis. Particle at position time greater than 0 is given by this function. Which of the following expressions gives the total distance traveled in the first 4 seconds? Okay? Total distance in the first 4 seconds goes from 0 to 4, obviously. But all these are from 0 to 4, so it really doesn't matter. Okay? Which gives the distance traveled in the first 4 seconds? Now, if you look at the graph of this, so if you go x squared minus 4x plus 7, y equals clear. And if we go, or x cubed, so x cubed minus 4x squared plus 7. And if we graph it. Okay. So what happens here is, here we go. Total distance is the integral of velocity, right? What is this? Position. So what we have to do is take the first derivative of this. So the first derivative of y sub t equals 3t squared minus 8t, factor out the t, and we get 3t minus 8. So t equals 0 and t equals 8/3. Okay. So they when they made this problem, they put pi over 3. Those are all supposed to be 8/3. They made a mistake on this test. Okay. So then we have to integrate this function. Now, yes, integrate that function. Now, we have to know that it crosses the axis at 8/3 and it crosses the axis at 0. Okay. So let me put in that function. And you're wrong. 3t squared minus 8. If we look at this graph, it's either C or D, but what am I doing wrong here? Let's look at the original function again, because I think that's what I wanted. So it's x raised to the third minus 4x plus 7. Okay.
What does that mean? What everyone's doing.
So what's happening is it's going down between 0 and 8/3, and then it's going back up after 8/3. So it's negative for the first part and positive after that. So it is choice D, because it's negative and then it's positive. So that's why it's D.
Is that because it starts negative then goes positive, or is it because the first going
It's negative from 0 to 8/3. The function is. So that's why it's negative there, and it's positive from 8/3 to 4. Okay? All right, this one. Now, it's the most important thing to look at in this one is there's an 8 there. It's backwards. So really, this one's the integral from 0 to 8 of f of x dx of a positive 23. So from 0 to 8, it's 23. From 0 to 4, it's 10. What's left from 4 to 8? 13. Very good, Mr. Ricky. Okay. All right. If this is the first derivative, what's the function? What do we have to do to the first derivative to find the function? Integrate. So it's the integral of 3 sine of x plus 2 cosine of x, which is negative 3 cosine of x plus 2 sine of x plus c. Okay? So if f of 0 is 5, okay, 5 is equal to negative 3 times the cosine of 0 plus 2 times the sine of 0 plus c. Well, 5 is equal to, what's cosine of 0? 1. So it's negative 3 times 1. What's the sine of 0? 0. So that's 0. So negative 3 plus c. So c must equal 8. So if c equals 8, is choice B.
Yo, I'm gonna fail this test.
Okay. The graph of the function is below. What's true about the function at 5? Is it continuous? Yes, it is continuous. Continuous means it keeps going. Is it differentiable? No, it is not differentiable. Okay? So, the first derivative of this function is undefined because it's not differentiable. F of 5 is defined because it is continuous, and it doesn't have a value because it's undefined. So yeah, it's undefined. Because when it goes to a point, it's undefined. Because the limit going this way and the limit going this way are not the same.
What would C look like?
See? There. A curve. Yeah, a curve. So this right here would be a first derivative of 0. And be a local max. There, Trey. Yeah. Okay. Here's a function defined by that. What's the area between the x-axis from there to there? Well, this is a simple calculator problem. So it's e to the x squared over 4, graph it. Is it negative x squared? Oh, I can't read. So it's negative x squared, so I got to insert that. And then you go second trace 7 from negative 1.65 to 1.65. And boom, it's 2.682. Total calculator. Average value of a function. How do we do average value of a function? It's the integral of the ln of x squared from 4 or from 4 to 2 here divided by 2, which is 4 minus 2. Okay? So do that. So second trace, or y equals, clear it out. So then you go parentheses, clear, parentheses, the ln of x squared, graph it. Go second trace 7, go from 2 to 4, and then divide that answer by 2. Okay. The next one, I don't know why it's in the calculator section because it's a total non-calculator problem. It's the fundamental theorem of calculus. Okay. When you take the first derivative of an integral, you just put the number in. It's a cosine of 3x times the first derivative of what's up there times 3. So 3 cosine of 3x. That is so easy. Fundamental theorem of calculus. You take, when it's the derivative of an integral and you have a number up here with a 0 on the bottom, you just stick the number in and then take the derivative of that number up there.
How is that pretty simple? There's no
Well,
way you
it's
can
the
see a problem
derivative.
like that. It's
Bro,
like
it's
fundamental
just
theorem.
What is simple? Where did you guys get?
Okay, Trey.
Move on, I don't care. Oh my god, I'm so confused, bro. You just wasted time.
So Trey, what would this answer be? No?
10 sine of 10x.
10 sine of 10x.
Oh yeah, I see how you got it.
Wouldn't it be top instead of x?
Because you're taking the derivative of the integral.
Yeah, it is an actual oopsies.
What? What? Right. Right, because you're putting in the x. You're putting in 3x, and I take the, yeah. All right. Shh. All right. Now, this one, you just have to understand concavity. Okay? Where is it negative and decreasing? Well, it has to be a negative slope, and it basically has to be concave down. So what is both negative slope and concave down? A. The first derivative is negative, means the slope's going down. The first derivative is decreasing, means it's concave down. Because that's the second derivative being negative. All right. Shh. Okay. So, where's the first derivative negative and it's increasing? Where's the first derivative negative and increasing? B, because it's on the negative slope, but it's concave up. And D would be increasing, increasing. Where's the, or positive and increasing? All right. The radius of a sphere is increasing at a rate proportional to itself. Okay? This one I didn't know how to do myself. This one I had to look up because I was lost. So you've got, hey, when you hit a problem like this, you got a 25% chance of guessing the right answer. All right. And it's not that. All right. If the radius is 4 initially and the radius is 10 after 2 seconds, what will the radius be after 3 seconds? So what I figured for this one is it has to be one of those rate of change ones where you take dv, dt, and d and that. Guess what? I was wrong. It's not one of those. It's a y equals c e to the kt problem. Okay? Which these problems aren't too bad if you would understand it's a y equals c e to the kt. So the radius is 4 initially. Okay? So what is c if a radius is 4 initially? 4. So y equals 4e to the kt. And it's 10 after 2 seconds. So time is 2 and it's 10. So 10 equals 4e to the k times 2. And we solve for k. So divide by 4, 2.5 equals e to the 2k. What do we do to each side? ln it. So the ln of 2.5 equals 2k and divide by 2. So we want to find the radius after 3 seconds, right? So y equals 4e to the ln of 2.5 over 2 times 3. So you put it into your calculator because we're on the calculator section. 4e raised to the parentheses ln of 2.5, close that parenthesis, times 3 divided by 2, close that parenthesis. Bang, and it's A.
I told you it's A, bro.
So if it's at a rate proportional to itself, it's a y.
C to the KT. Yep. Because if it's going up by proportions and that. Totally blew me away. Did not see that at all. All right. Suppose we have this. What does this look like when we have something like this? Yes! The fundamental theorem of calculus.
The only person I've ever seen get so excited.
All right. So, it's a fundamental theorem of calculus. So what do we do with that x? Put it in the x. So it's x cubed plus x. Okay? Now, x cubed plus x at 5. Throw in the 5. What's 5 cubed?
125 plus 5.
That's it. Fundamental theorem of calculus is fairly easy because this is the first derivative. So if we take the first derivative of this, then you just stick the number in and stick the number in. I don't know that answer yet. I don't know. I got to talk to Mr. Shaw. We'll see what he says. All right. What I think you should do that day is for all the classes you miss Monday, it should be just a work session to make up your work. And if you're done with all your work of the classes you do Monday, then, whatever. But we'll see if Shaw goes for that. All right. When we integrate a natural log, okay, it's not 1 over x, remember? Okay, so u equals 2x, du equals 2 dx. So we need a 2 here, so what goes out front? Now, 1/2 goes out front. So it's 1/2 the integral of the ln of u du. Okay, what's the integral of the natural log? No, the derivative of the natural log is 1 over x, isn't it?
It's E. C.
2x ln 2x
Oh,
minus 2x
okay.
plus c.
I'm doing this wrong. Sorry. Because we can't do that, can we? So then we have to make u equal the ln of 2x. Then what would du be? What's first derivative of the ln of 2x? 1 over 2x times dx, which is times 2. Okay. Oh, okay. This is one of those. All right. This is something we never did in class. Sorry. This is something we never did in class. This is something that, you know how I showed you the other day to put notes into your calculator?
When you went really fast,
Yeah.
I didn't get to know how to do it.
So this is a formula to memorize. So the integral of an ln of something times x dx equals x ln of ax minus x plus c.
I remember that.
So it is choice C. We never did that in class.
I remember it. I went home and learned it myself.
Okay.
Because he just said it and I guessed it.
Where does the 2x come from?
The 2x is from the original problem
Yeah. Well, why are you saying that?
because it's the ln of 2x equals x times the ln of 2x minus x plus c. Because a is 2. All right, let's move on. Okay. For this one, 43. Okay. Now, find all values of a and b that make this differentiable. Okay? To be differentiable, Ali Vacanti, to be differentiable, what do we need to have happen when we had these piecewise functions first semester? They had to do what? Be equal at 2. Okay, they had to be equal at 2, so you set them equal to each other. So ax squared plus 3bx plus 14 equals 3ax plus 5b. Okay? All right. Then it had to be where x equals 2 at, correct? So if x equals 2, stick the 2 in. So it's 4a plus 6b plus 14 equals 6a plus 5b. Okay? Now move everything to the left side. So you get negative 2a plus b equal, or plus 14 equals 0. So negative 2a plus b equals negative 14. Okay? Now, which of these will work if negative 2a plus b equals negative 14? Does negative 6, 2 work? No. Does 6, negative 2 work? Yes. 2, 6 doesn't work. 2, negative 6 doesn't work. Okay? You chug and plug. Okay? The bell's going to ring. And so then we'll do these two, and then we'll go over the word problems after lunch. Oh, we got a minute yet. I can do one more in a minute.
I think we are already out the door mentally.
Oh, really?
I've been mentally out the door since
Hey, how do you
January,
say this,
but
Olivia?
And then I put this sweat. I did not cut my hair.
I found
All right, so after lunch, we'll look at the circle as it's changing with the rates. Yeah.
How much is the diagnostic worth?
Diagnostic is worth what I decide to make it worth there.
I feel like that's
remember, I got my hair cut or
How is that unfair?
Because like I've been trying.
Oh, absolutely.
Like